Hi there, folks. I'm going to do a little calculus video on determining intervals of increase and decrease for a function. So to introduce this, when you're looking for where a function's increasing or decreasing, you're looking for where the y values are increasing or decreasing, so going up or going down as the x values change. So from a graph, this is quite easy to see, because what you would be looking for is where are the y values on this graph, so such as this point right here, the y value is -1, -2, -3. The y value is at -3 at this point, and as that circle moves along, it goes up to +3. So the y values here are increasing. And in fact, that graph increases on the entire interval until it gets up to this point at about x equals -5 or so. So for all of these values, that graph is going up. For all values that are less than -5, the values are increasing. Then this height starts to go down, so it's decreasing until it gets to some point over here around x equals 0. Then it starts to increase again or go up, and then it decreases again and goes down. So there's places where it's increasing, right here, I'll put INC. Between these points, it is going down, decreasing. From here over, it is increasing, and then for the rest of them, decreasing. So it's really the height. If you think about it as the height of this circle, the circle's height is going up, increasing function, going down, decreasing, increasing, decreasing. So as the height changes. To get some math onto that, this interval would be all x less than -5. The interval here would be between -5 and 0. So there's another interval. This interval would be between 0 and 4. And this interval is all x greater than 4. So from a graph, it is easy to determine where it is. Now so there's no calculus involved in this yet. This is really just looking at where functions are going up and down. Where calculus becomes involved is when you want to do this from a function. When I don't give you the graph, when I give you the equation, how are you going to solve it from an equation? Well, what you can visualize, if I still stay with the graph for a minute, if we visualize slopes of tangent lines, so if I drew a green dot here, and imagined a tangent line that just touches that graph. The slope of that line is positive in any place where it's increasing. But if I put a slope of a tangent line over here in the decreasing interval, the slope of that tangent line is negative. So slopes of tangent lines are always positive in increasing areas and always negative in decreasing areas. This is where the calculus comes in, because slope of tangent line is just the derivative f prime. So if the derivative is bigger than 0, folks, that means positive. If it's bigger than 0, then your function is increasing. And if your derivative is less than 0, because derivative means the slope of the tangent line, if your derivative is less than 0, i.e. negative, then it's decreasing. So all of a sudden, you've turned what is your graph visual cue into a formula. If I give you the formula, you need the derivative, and then you need to figure out where is it positive and where is it negative. Well, if you're going to figure out where it's positive and negative, you better figure out where it's equal to 0, and then you can test. So to determine an interval of increase and decrease from an equation, we got to do a bit of work. What you're trying to do is figure out where is the slope positive and where is it negative. So you need to know where is it equal to 0. So the steps I get my students to do are: step 1, figure out the actual derivative. Step 2, set that derivative equal to 0 and solve it, which is sometimes easier said than done. And step 3, we're going to create an interval table to test where is it positive, it being the slope, where is the slope positive, where is the slope negative. Or instead of slope, think of it as the derivative f prime. Okay, so that's the theory. 5 minutes of quick theory involved in this. Let's get this right into some action, into some questions. So in our textbook, this was question 4C, but this example works just fine. We're going to find out the intervals of increase and decrease for a function x to the 4 minus 2x squared plus 16. So step 1 was figure out the derivative. So if this is your first time doing derivatives, you need to check out some of my derivative videos because I'm just going to jump in like you know what you're doing. So the derivative of this function is 4x cubed minus 4x, and then, of course, derivative of 16 is 0. So your derivative, 4x cubed minus 4x, I'll take a common factor out. You get 4x onto x squared minus 1. That's my derivative. I see more to factor here. That's a difference of squares. So your derivative, if you fully factor it, would be 4x onto x plus 1 and x minus 1, because that just factors to this. So now I have a fully factored derivative. Step 2 says set it equal to 0. Well, now that we've got it factored out, if there's 3 things that multiply to give 0, the only way that could be, you set the first one equal to 0, you set the second one equal to 0, and you set the third one equal to 0. So here, solving, you have one answer. That's where the slope is 0, is when x is 0. You also know the slope is 0 when x equals -1, and you know the slope is equal to 0 at x equals +1. Well, there's step 2 done. You find out where it's equal to 0. Now we're going to test numbers and find out where is it positive and where is it negative. So we're at the step called create an interval table. So I'll move the next question down a little bit more. So the way I get my intervals is I think of these 3 numbers on a number line, and they're not in order yet. So I'm going to create a little number line here. Putting them in order, you'd have -1, 0, and +1. So my intervals of all the numbers in the universe are numbers less than -1. There's one interval. You have between -1 and 0, so -1 and 0. You can be between 0 and 1, and all x greater than 1. So I have 4 intervals to test. So I'm going to create a table that has all 4 of those on it. So I'm going to have x less than -1, between -1 and 0, between 0 and 1, and x greater than 1. These are what I'm going to have as intervals to test. Now, take a second to draw this out. What do I place at the top of this table? I'm going to put all of the factors of my derivative, 4x, x plus 1, and x minus 1. And I'm going to create each of those factors as a column. This isn't the only way to do it. It's just a nice structured way that I like to show. So we'll put 4x as one column, x plus 1 as another column, and x minus 1 as a third column. And then we're going to summarize that all up. So I'll just draw a second line, and we'll put this as the entire derivative. I guess it's g prime of x. Okay, so we'll move this stuff over a bit. Okay. So what you're going to choose in this interval table is choose any number that is less than -1 in this first interval. So choose a number like -2. Plug -2 into each of these spots and tell me if it's positive or negative. You don't need to work it out. You just need to tell me if it's positive or negative. If you put a -2 into 4x, that answer is negative. If you plug -2 into x plus 1, that answer is also negative. If you put -2 into x minus 1, you get a third negative. G prime was determined by taking those 3 things and multiplying them together. If you multiply 3 negatives together, you get a negative. That tells you that this function is decreasing on x less than -1 because the slope of the tangent lines are negative there. So back to my other graph, that's where the values are going down. Choosing a number between -1 and 0, like -1/2 is the number I would plug in. -1/2 times 4 is negative. -1/2 plus 1 is positive. -1/2 minus 1 is negative. Two negatives and a positive, when multiplied together, gives you a positive. It is always increasing here. If your slopes are always positive, then the function is getting bigger. It is increasing. Choosing a number of a half, which is between 0 and 1. This is positive. 1/2 times 4. 1/2 plus 1 is positive. 1/2 minus 1 is negative. Two positives and a negative multiply to give a negative value. This shows that the function is decreasing in that interval. And the last interval, choose any number bigger than 1, like 2 or pi or anything. 2 times 4, positive, positive, positive. 3 positives make a positive for the derivative, and it is increasing on that interval. So we have shown the intervals where the function is decreasing and where the functions are increasing. It is decreasing on x less than -1, and it's decreasing between 0 and 1. The other two intervals is where it is increasing. At those points is where it's actually equal to 0. So let's try one that's a little bit harder to take the derivative of, but it's the exact same steps. So if you had a function like h of x, where you have 1 minus x squared, all squared, what you have to do with this function is use the chain rule to get its derivative. So our h prime of x, the chain rule, we bring that power down to keep the bracket the same, reduce the power to 1, then take the derivative of what's inside the bracket. And the derivative of -x squared is -2x. So this is my derivative. So 2 times -1 minus x squared and then times -2x. I'm not going to fancy around too much with that, I guess, but I will take this -2x, multiply it by 2, so I guess we'll get -4x. We'll put those together. But I will take 1 minus x squared. No self-respecting mathematician would leave that the way it is. That's a difference of squares. 1 plus x and 1 minus x. So there's my 3 terms that multiply to give the derivative. We set that equal to 0, and you will get points of 4x equals 0, -4x technically, 1 plus x equals 0, and 1 minus x equals 0. So my roots are 0 divided by 4 is 0, x equals -1, and x equals +1. So again, my value, setting those 3 numbers up on a number line, -1 and 0 and 1. I have intervals less than -1. I have intervals between -1 and 0. I have intervals between 0 and 1, and intervals greater than 1. So my 4 intervals I need to test with these 3 factors at the top of my table. Okay, so I went ahead and started to fill in the table, or create a table at least. My intervals, if you recall, are x smaller than -1, between -1 and 0, between 0 and 1, and x bigger than 1. My factors across the top are -4x, 1 plus x, and 1 minus x. And the whole thing will be the derivative h prime of x. We're looking to see if that's positive or negative. Choose any number less than -1. I'll choose -2. -2 times -4 is a positive. -2, so 1 plus -2 is a negative. 1 minus -2 is a positive. This whole thing is a negative, so that's a decreasing interval. Plugging in any number between -1 and 0, I'll choose -1/2. Throwing in -1/2, you get a positive here. -1/2 positive in the second column. -1/2 positive in the third. And you get a positive interval here. It is increasing. Between 0 and 1, choosing 1/2. So throwing a positive 1/2 in times -4, you get a negative. 1 plus 1/2 is positive. 1 minus 1/2 is positive. A negative and two positives makes a negative, decreasing on that function. It usually alternates, but it does not have to. You should continue with this test. Don't just make the assumption that if the first one's negative, that it's going to go back and forth. It will not always occur. Choosing a number bigger than 1, like 2, -4 times 2 is a negative. 1 plus 2 is a positive. 1 minus 2 is a negative. Two negatives make a plus. So the function's increasing on that interval. All right, one last example, and I'll do a second video with some harder ones. So this example shows where a quotient rule is going to be needed if your function is x minus 1 and x plus 1. So this is the function you're going to take the derivative of. If you recall, we'll use quotient rule with this, f and g. If you have two things being divided and you want to take the derivative, your rule says f prime g minus fg prime all over g squared. So we will take the derivative of the top, so x minus 1, its derivative is just 1, that's f prime. G, you leave the function the way it was. F is x minus 1, and g prime is 1 all over x plus 1 squared. This is the derivative h prime of x. That's what we're working on. So simplifying this, the numerator, so our derivative h prime is x plus 1 minus x plus 1. As the minus x goes on both terms, you still have x plus 1 squared in the bottom. X minus x makes 0. 1 plus 1 makes 2. So your derivative, h prime of x, is 2 over x plus 1 squared. So step 1. Okay, so the first step was figure out the derivative. Second step is set the derivative equal to 0. Well, if you start to set this equal to 0, you're going to notice a problem because you're going to cross multiply and you're going to get 2 equals 0, and where's the x? So there must be something else going on here. Well, what that means is this function's always going to be positive or it's always going to be negative. It doesn't change. Well, look at the function that you've written. You have 2 on top. It doesn't change. 2 is always positive. Look at the denominator. It's squared. It's always positive. You can't put a real number in there, square it, and get a negative number. I don't care what you put in. You're squaring it. It's going to be positive. So this function is always positive, and if it's always positive, then it's always increasing. This is a function that doesn't increase and decrease. It just always increases. There's also something funky going on at x equal -1, and it behooves you to at least look at that, but that comes into critical points, max and min. You really should consider that at -1 something's going on. It's not just a clear-cut graph. There's more to it, but I'm not looking at curve sketching or graphing, just looking at intervals of increase and decrease. If you want to set up a number line and check what happens left and right of -1, because it seems to be a point where something critical is happening, you can look between x minus 1 and x greater than -1. But again, an analysis of the derivative shows that it's always increasing because it's always positive. So you don't really need to check left and right because the function's always going to be positive. I don't care what you plug into it. All right, I'm going to do a second video of some harder factoring questions and harder to do, but there's a good start for you to just learn the concept.